All right, welcome back, everybody. We are now going to look through some of the ways of running linear regression in SAS. In this course, I provided you all with two data sets, the ice cream data set and the real estate data set. Now, one of the first things you all did was to upload this data set. So we have ice cream and the real estate data set. It's in CSV format. Now, the first question is, how do you upload a CSV file? Up here, you have download, and up here, you have upload. If you click on this, then you can upload this from your computer. You can upload the file from your computer, and you indicate the path where you want to upload it to. So that's how to upload a CSV file. Next, how do you read a CSV file? Now, SAS is quite intuitive in the sense that if you do not know the code procedure, you can simply just click on this file, just double click on it, and it generates a code for you automatically, which you can use to actually read this file. So it generates this code without my writing anything. The code is already pre-generated for you. Simply run this. And then you have the file created. If you go now to the libraries, walk, you can see the ice cream data set that we have just initiated. So basically, we can go back to the code segment. Let's go out of the log. So that's the log. You can go back to the code and simply copy this code and use in your program. So that's one way of exploring how to read a file. Oh, by the way, no, the file that we just read is in imports, not the ice cream. I had read this previously, apparently. So you can now change this name to whatever name you want to use. So if you click on imports, here you can see the data sets in the ice cream CSV file. We have 4 columns, consumption, income, price, temperature. Now you can copy this file, create a new SAS program by pressing F4 and paste it, and you can change this to a new name. So let's call this My Ice Cream, for example. And let's rerun this again. Now, if you look at my library on the walk, you can see there is an error. So let's check what the error is. So look at the log. My work data does not exist. So let's go back here and fix the bug. So we need to change this to My Ice Cream as well. So the beauty of running SAS code is that whenever you run a code, always check the log to see what the error is, and that way you get to fix the error. And so we come back here and now rerun the code. And now let's look at the log again. Now there's no error. And if we check my libraries on the walk, now we can see My Ice Cream that is being created. So that's how to read the file without even thinking about what's the code? Should I look through the SAS documentation or not? So that's the first thing I wanted to address, how to read the file. Now, after we have read the file, So now we have a code to read the file. Now, what else can we do with this file that we've read? So let's say we are going to explore my ice cream file that we have read. So up here, you could write a comment that says read in ice cream data, and press Ctrl/, and that creates a comment for you. And so this is your codes that you're creating. And under here, you can copy another new set of code and populate into this file. Next, let's summarize this data that we have imported. Let's look at the summary statistic. How do you do that in SAS? The beauty again of SAS is that you have this task and utilities. Click on that and go all the way to statistics, and then look for summary statistics. Now, double click on summary statistics, and in here, enter the data sets that you want to summarize. So click on this button. Let's go to work and let's choose my ice cream. And of course, we have not selected any variable yet. So in here, we have no code generated. But you can see a very fanciful comment that has been generated for us. Now click on this plus button and let's highlight everything by pressing Ctrl+A and press OK. So in here we have the variables that we want to summarize. So this is the default setting. We have the mean, standard deviation, minimum, maximum, the number of samples, and so on. But let's assume we want something different. So how do we change that? Click on options. And let's take, for example, I'm not interested in number of observations, so I would unselect it. And let's look at additional statistics. Now, let's take, for example, I'm interested in looking at the skewness and kurtosis in order to test for normality of the variables. So I select that. And what do you see? It adds it to the options here. You have skewness and you have kurtosis. And perhaps I'm not interested in any of this, or let's say I'm interested in the lower quartile and the upper quartile. I could also select that as well. And let's say I'm also interested in a histogram of each of the variable. So you can select histogram, and suddenly you have the procedure that will generate the histogram created for you. Now let's assume that that's all I need to summarize and visualize. I can then copy this code, move over to my program that I'm trying to create anew, put up a comment that says summarize data, and I press Ctrl/, and then beneath it, I paste my code. I didn't write this. It's auto-generated for us. Now you can highlight this code and click on run. When you do that, you get the summary statistic. So we can see the minimum, the standard deviation, the mean, the standard deviation, the minimum, maximum, skewness, kurtosis, first quartile, and the third quartile of each of the variables. And we can look at the distributions of each of the variables as well, which is basically the histogram of each of the variables. So that's how to summarize our data and also visualize each of the variables. Next, let's assume we want to run a simple linear regression whereby we want to look at the association between consumption of ice cream and temperature. So we want to be able to predict the consumption of ice cream based on the temperature outside. Now, how do we go about that? So basically, we go to linear models, and we have linear regression right here. But before we run a linear regression, it's always nice to create a scatter plot of the two variables. So let's go back up here on the graph. We have scatter plots. Now you can double click on scatter plots, and right here you change it to, you check that you have the data sets that you want to examine, which is my ice cream. Yes, my ice cream, not yours. And for our x variable, which is our predictor variable, we are going to insert temperature. And our y-axis, which is our response variable, we are going to select consumption, which is cons. And behold, we have our code. Now we can copy this again, or you can just run it directly from here if you don't really need this code. Now you run here, and we have the outputs. So we can see that there's a sort of a linear relationship between temperature and consumption. As the temperature increases, the consumption of ice cream also increases. Of course, you can do some other things on this. You can add a regression best fit line on it. You can label, you can add titles to the to your charts. You can add a footer. You can do so many things, and it will automatically generate the code for you. And when you're done again, you run the code, and now we can see the line of best fit added to this. Okay, good. In a real class, I would have asked, are there any questions? But if there are, you can let me know after watching this video. Next, now let's run a linear regression. We can see that there is a sort of a linear association between the two variables through the scatter plot. So now we can run a linear regression. If there was no linear relationship, then there's no point running linear regression. So click on linear regression, double click on it, and it brings up the linear regression task. And here again, we have our data, my ice cream. And for our dependent variable, which is our response variable, we're going to select cons. And our explanatory variable or predictor variable is a continuous variable. So here we select temp, the temperature. And you would expect to see a code right here, but there's one more thing you need to select. You click on the model, you want to add the model effects. Click on edit and select temperature and click add. And so this adds temperature as as the model effects, and click OK. And now it's going to generate the code for you using the procreg procedure. So this is the code you could write on your own if you're familiar with SAS, but if you're not, the beauty of SAS now is that it's kind of a point-and-click application. Now you can copy this, and let's go back to our program. And right here, we can put a comment that says, run simple linear regression. And control forward. Okay, then below it, let's paste our code. And now let's highlight that section alone and click on run. And behold, we have our results. We can see the parameter estimate. So this is our beta 0, and this is our beta 1. We are always interested in the slope and not really the intercepts. And we can see that this variable is statistically significant at alpha is equals to 0.05. That was our significance level. We can see that the p-value here is less than 0.05. So we say that this variable is significant. And with these, you can also create the equation of the line from this. So we have that the consumption of ice cream is equals to the intercept value plus the temperature estimate, parameter estimate times whichever new temperature you want to predict. So that will give us the equation of a line, and that will be this prediction line that we can see right here. So those are basically the outputs that we have explored so far in the class. One other thing that you might be interested in that we've talked about is the R-square value to look at how good the model is. So here we can see that the R-square value is 60.16%. So 60.16% of the variability of the response variable is explained by temperature, by the predictor variable. All right, so that's how to run a simple linear regression. Now, what if we want to look at the confidence interval for the estimate? So we want to look at the 95% confidence interval, whereby we can say that we are 95% confident that the true population temperature would be within a certain range. How do we go about that? Let's go back to our linear regression procedure and click on options. Now, in here, so we can see here that our confidence level is 95%. Of course, you can change it depending on what you decide for your research. And there are all this, if you're not interested in the diagnostics, which we're going to see later in the course, you could simply just unselect that and unselect that. Unselect that. So that will give you no plot. So you can see plot is equals to none. And basically what we're going to do here is I will copy this code, go back again to our program, and I'm going to paste it down here. So this new code would have no plots. And right after this /, I'm going to type CLI, and that is the confidence. It will construct the confidence level. So that's the option CLI, and the build here you can see you can look at the help documentation to read more about CLI option. Now we run this code. And in our output here, we can see the 95% confidence level for also provided as well in the outputs. So that's pretty much it for now. What else should I go into? So let's see how to make predictions. So assuming I want to make prediction that what would be the value of the temperature if the temperature is 50, how can I do that in SAS? So for these, we need to add in our data set, we need to add a column for when the temperature is 50 in order to predict what the consumption would be based off our model. How do we do that? For this, there are no task option, unfortunately, that will do this for you. So I have provided you the code. Here is the code. And I will explain this code. So up here, what I'm doing here in this data procedure is to create a data procedure in which I have one variable called temperature, which is assigned 50. Now, if we run that alone, and of course, my phone was not muted for this live call, so let me unmute it, or let me mute it, sorry to say. You can see that we have temperature and we have 50 provided there. Now, the next thing we want to do is add that into our ice cream data. And this time around, we want to add it into my ice cream, since that's the data we are using. So I change this to my ice cream. And let's run this, and then we want to create a new data set called ice cream predict. You could call it any name you want. And so when we run that, now you can scroll all the way down and you can see we have the section that says temperature is 50, but we have no value for the consumption yet, because we have not yet created a model that would predict the consumption of ice cream. But what we have just done is added this into our data sets. Now, here we're going to run a progress procedure where we are running a simple linear regression, and we want to also find the confidence level, and it's going to present that for the temperature value that we have just added. So this will help us in creating a prediction interval. Now, let's highlight this again and run this. And now we have this section that says out dependent variable cons. If you scroll all the way down, here you can see this column is the predicted value. So the predicted value for when the temperature is 50 is 0.3622. And the confidence level is between 0.2742 and 0.4502. All right. So that's pretty much everything for simple linear regression. Next, let's explore the other data sets, and let's move to the real estate exam and data sets. Again, now let's assume we are done with this initial program. I can close this. Don't save it. Close this, we don't need it, don't save it. You don't need all the stacks, don't save it. But what we only need, we also don't need this, so it's always nice to make yours. We are done with my ice cream for now, but now you can now save this program. So let's assume this was your homework assignment you're doing. So you can save this program, save, and indicate the location where you want to save it to. So let's assume I'm saving it to this folder called Applied Data Analytics. So I click on Code and say class practice. So that's the name of my file. I can just call it my awesome code. My awesome anything. Well, or programming assignments 2, for example. And then click on save and wait a bit, and we can see here programming assignment 2. So we're done with this, so let's close this. If we want to download it, we just highlight it and click download, and voila, you have your programming assignment 2 downloaded to your PC, and you can then upload this to Blackboard. Now let's look at the other data sets. We want to now explore the real estate data set. Again, I just uploaded the CSV file. How do I read this data file? Double click on it. SAS automatically generates a code for us. Copy the code. Create your own new file, paste the code, and in here, let's change this to my real estate. My real estate. And change this also to pretty much, we don't really need to look at the content. So all we can just delete this. This is not necessary. All we need is just to read the file and have it stored in the work in this library called work. Or you could create your own library and store your data set in that library. But this is all we need to read the data. Now, assuming we don't need all this heading, so you can remove it and just call it read data, // and that's a comment. And you run this code. Wait a bit. It's a large file with several columns. So it's going to take a little bit of time. At this point, you can get water to drink. All right. So here we can see the data that has been read. There are 6 columns. We have price, living area, bedrooms, bathrooms, year, and garage. And there are 894 rows. So that's how to read the data. So we have this, and now we have this. If we look at libraries as well, my library, on the work library, you can see my real estate that has been read. We pretty much didn't do much. We just clicked on the different buttons. All right, so what should we do next? Let's assume we want to summarize this data as well. Again, you should be familiar with this from what we did earlier. Let's click on task, and we're not looking at the graph or statistics. Summary statistics, double click on that and change this to my real estate and click OK. Now in the analysis column, Ctrl-A to highlight all of them, all the variables, and click OK. And there we have provided this code. You can copy this to go back to your program, and right under here you can say summarize data. And Ctrl//. But let's go back here before we move. Assuming that we should click on options to select the options we want. I'm not interested in number of observations, so I remove that. This time around, I'm not interested in kurtosis or skewness, but I would like to see the first quartile and the second quartile, for example. So I add it there. And now I can copy this code, move over to my program, and beneath here, paste it. So now you can now highlight this and run this. And here you can see the summary of the data. So price, you have the mean, the standard deviation, the minimum, maximum, first quartile, and third quartile. So that's the summary. One other thing that we can do is when we have all these variables, we might want to look at the pairwise correlation. Now, one way of doing that is you click on correlation analysis, and here you can select all of this variable. I'll show you different ways, and simply just run this for now to see what this gives you, if this is what you want. So here we can see, of course, price to itself is going to be 1. When you're looking at a variable to itself, the correlation will be 1. But you can see the price to living area, price to bedroom, bedroom to living area, and so on and so forth. So this is a correlation matrix. Other things we could have done is, if we click on options, we might be interested in creating some of the plots, a matrix of scatter plots. and this is also known as a pairwise scatter plot. So click on the matrix of scatter plots and look at the code again. You would see that it has added plot is equals to matrix. Now you run this. Let's go back to the code. Plot is equals to matrix. And now let's run it again. Did I select it? Yes. Number of variables to plot. How many variables we have? We have 6 variables. Let's select 6 variables to plot. And let's run this again. For some reason, I'm not seeing the plots. Let's include histogram. Okay, I will have to fix this later on. Now let's assume I copied this and come in here. You know, most times when you're doing a demonstration, so many things happen behind the scene. This should work. Let's run it again separately. I'm curious. Yeah, we had the matrix, but why is the plot not showing? Plot is equals to matrix. Let me make this 4, and let me just remove this 2 for now and run this again to see. Okay, I think I know why. Let's see. So in here, if we look at the log, it tells us the warning. The scatter plot with more than 5,000 points has been suppressed. Okay. Use the max points equals to this. Use the plot's max points equals to that, and that was used. Okay, let's change this. Let's delete all of this, and we have just price, which we want to correlate with the rest of the variables. And also we want to add the scatter plots. I think this is the way that it's going to show. So when we run this now, so now we have what we're looking for. So for us to get this scatter plots, we need to set our primary variable of focus, which is price, a dependent variable, and we are trying to correlate it with the set of variables. So when we had everything in the year, it didn't really know which was the primary variable of focus. However, this is not what we want. We want it the other way around. We want the price variable to be the y-axis and the other variables to be in the x-axis. So again, you highlight this and you delete this. That's really not what we want. And delete this off. And now in here, let's select all of these variables. So that will now, this will now be the analysis variables here will be in the x-axis. And now we want to correlate it with price. And you run this, and we get what we want. So what I have demonstrated here is that sometimes when you don't get what you want, you don't give up. You really have to look deeply and say, okay, what is the problem? How can I fix that problem? That's really what we need to be able to do. Now that we have this, we can copy this code, because now this gives us what we want, and go back to our main program under here, and I will give a heading and say pairwise scatter plots. So this provides us the pairwise scatter plots. And that's it. So this is the pairwise scatter plots. At the end of this video, I would also download this whole file and also share it for everybody in Microsoft Teams. Now we have this. Again, we can run this from here, and we have our scatter plots. And of course, we can download this in a Word format and use this file in a presentation, for example. Great. Now, of course, at the start of any data analysis, it is always helpful to examine the pairwise correlations between your variables. It's always very important. Now that we've looked at this, because when you look at this result, we can see that there's a sort of an association between each of the price and living area, price and bedroom, and so on and so forth. But anyways, let's move on. Let's jump right into multiple linear regression. So how do we run multiple linear regression? Just like we did for simple linear regression, we go to linear regression. Click on that task, and we have our data of interest, my real estate. And now our dependent variable is price, and our independent variable are all continuous. So we select this, Control A to highlight everything, and click OK. And now we click on model, click edit, highlight everything here, and add it. So those are the model effects, all added, and click OK. And with this generates our code. Now, of course, there is an option. If you want to change your confidence level to 90, you can change it to 99 based on your research decisions. And for the statistics, let's leave it as default. Diagnostics plots, we've not gotten there yet, so I'm just going to remove that. Residuals for each explanatory variables, I'm going to unselect that. Click on scatter plot. Observed values by predicted values, I don't want to show that right now, so I remove that. Now we have what we need. I can copy this code, go back to programs, and add a new comment that says run multiple linear regression, or run multiple regression. Okay. / and press Ctrl V to paste, and let's select this, run this. And that's how to run a multiple linear regression. And right here, it gives us all the parameter estimates as we want. So that's the intercept, and these are all the beta values. And here we have the p-values. We have the p-values for the inclusion of each of these variables. Now, in other words, whether each of these variables is statistically significant beyond the effect of the other variables that are already in the model. So that's what this is. So we can see that year and garage are not statistically significant because it's not less than 0.05. Well, these other variables are statistically significant. Now, based on this model. Also, we can also interpret the adjusted R squared. So the adjusted R squared here is 18.07. This is pretty low. And we discussed this during the live sessions, basically. So that's how to run a multiple linear regression. So again, how do we interpret this R squared? So like I said, we have 18.07 of the variation in prices is explained away by including 5 different predictor variables in the model: living area, bedrooms, bathrooms, year, and garage. So that's really the interpretation. All right. How are we all doing? Feeling good? This is going to be an hour video. Next, we can look at we might be interested in looking at the correlations between price and, let's say, bedrooms and garage alone, because our price, bedroom. So here we can also, because we see here the bedrooms we have negative, so the parameter estimate gives us a negative value, and here is also negative. But when we looked at the scatter plot, we felt that there is a positive linear association between these two variables. So let's look at the correlation value of price and bedrooms and year, for example. You can also look at garage. Again, this is just for a revision. We go on correlation analysis. And our analysis variable is select bedroom and year. And we want to correlate it with price. And you can click on this. If it doesn't give you what you want, then you can make some changes. So here we have price, and we have bedrooms and year, and we have the correlation values. So we can see that this is positive. So I can get the correlation between these by running these procedures. Now you can copy this code if this is part of what you need to submit. So what we just did here is looking at the correlation between price and bedrooms and year, and that's pretty much how to run these procedures. And with that, we are actually coming to the end of this presentation on how to run simple linear regression in SAS and how to run the simple multiple linear regression analysis in SAS. Now, one last thing: what if we want to make predictions and predictions interval for new data, like I showed in the slide? How do we go about it? Now, again, for this, there are really no procedures for that, and I have created the codes for that. Now let's go up here. But before we move to that, let's save this file. And what did I save the other one as? Programming assignment 2. So let's save this one as real estate data analysis and click save. So we have real estate data analysis, and this one, let's rename it and call it ice cream data analysis. So we can rename our file right there. We have ice cream data analysis. Okay, sounds good. So we are pretty much done here. We don't need this again. Don't save it. We don't need the stats. Don't save it. I love to make my window much neater. So when I'm done with any procedures I don't need, just delete it. just close it, not delete. And we don't need this either. We also do not need this. Don't save it. So now let's open the prediction interval form. Yeah, so in here, what I just did up here is create a new data set called A, whereby I have these different fields as which is similar to what we have in my real estate. Now, by the way, this is going to be called my real estate. So let's run this part of the code. And you can see this data frame generated. You have living area, bedrooms, bathrooms, here, and garage. So this is the new variables we want to use to predict what the price will be when the living area is 3,000, the bedrooms is 3, bathroom is 2, year 1940, and garage is equals 1. So now we want to add this into our data sets. So if we go to my libraries on the walk, we have my real estate. And that's what we have here. We want to add this data. You can call it anything. You can call it B, you can call it Italma, and then you change this here as Italma. And just for fun, let's have this Italma. And now we run this. And now we have walk.italma. Yeah, Italma has to walk. Now come back here and change this to Italma. And now we run this. And what we just added has been added into the data sets. So what we added was price is 3,000. Unfortunately, in the output, there's no way of sorting this out, so we can just see it. But when we run the regression, we're going to find what we just added at the very end. Okay, just trying to see price 3,000. Eyeball it fast and see if I can find that. Otherwise, that's okay. I mean, living area 3,000. Okay, now, of course, if there was an error, we check the log if there was an error, but there's no error. So it means that this procedure worked fine, and this set of data has been added to this new data frame. And of course, you can also find it here. What we've just created, the real estate free. If you click on this, this gives you the data. All right. So, and if you look at my real estate, just to confirm our understanding, in my real estate, there are 894 rows, but because we've added one row, which I can find right now, we have 895 rows. So that means that one new row has been added to these data. So that's a way of verifying if this set of code just worked. So now we want to construct the confidence interval. So we want to construct the confidence interval, for the prediction of the home price based on these values that we've added. So when you run this, it takes a little while. Wait a bit. So much data. Okay, it was much faster. Now you have this these outputs. Scroll all the way down. I should have removed the plots, but what we want is this this last line here. How do we go about interpreting this after we have run this whole procedure? So this is what we've gotten. So we set the price of home with the living area was set to 3,000, and we have, with what we said, the price will be 531,657. So that is the estimate of the home price. And now the second two numbers here, these two numbers, if you look at the column, that's a 95% confidence interval. So up here we have the 95% confidence level prediction intervals. So I would say that I am 95% certain that the average price of home with these kinds of characteristics is going to be somewhere between $17,657 and $1,045,656. All right. So as we discussed in the live class, this very wide interval is likely influenced by this model not being a particularly well-fit linear regression model. That was what we established in the live class. So that's pretty much all there is. That's pretty much all there is. And now you are well equipped to start performing your own linear regression models in SAS. See you in the live class.